heat speed of light. 299,792,458 meters per second. Incredibly fast. The fastest phenomenon we've observed. But here is the real question. Why does this represent an absolute boundary? What prevents anything from exceeding it? Most people simply accept this as fact. Einstein declared it, light speed is the universe's ultimate speed barrier, end of story. But that is not understanding. That is merely accepting authority. When you genuinely probe why nothing can surpass light speed, when you examine what is fundamentally preventing it, you encounter something so profoundly counterintuitive, so radically different from ordinary experience, that it transforms your entire understanding of reality. Light speed isn't merely velocity. It is not simply the fastest phenomenon. It represents the fundamental architecture of existence itself. It is embedded into the very essence of space and time in such a way that exceeding it becomes literally impossible. Let me demonstrate what I mean. Begin with something straightforward, something universally familiar. Objects fall. Release something, gravity pulls it downward. 16 feet in the first second. Precisely that is Galileo's measurement. Release a ball, a stone, anything. Within 1 second, it descends 16 feet. Now consider the moon. The moon orbits Earth. It is not plummeting downward. It remains suspended, circling, following a curved path. But hold on, is it actually falling? Consider this carefully. If the moon were stationary in space, motionless, what would occur? It would plunge toward Earth. Gravity would draw it inward. However, the moon is moving. It is traveling sideways, tangent to its orbital path. And because it is moving laterally, while gravity pulls it downward, it continuously misses Earth. It falls toward Earth, but perpetually misses. That is the nature of an orbit, continuous descent while moving sideways rapidly enough to keep missing. Here is where Newton achieved his remarkable breakthrough. The moon sits 240,000 miles from Earth. As center, we stand on the surface. 4,000 miles from the center. The moon is therefore 60 times more distant than we are. Newton proposed, what if gravity diminishes with distance? What if it obeys an inverse square relationship? Meaning if you double your distance, gravity becomes 4 times weaker. Triple the distance, 9 times weaker. The square of the distance, if this holds true, then at the moon's distance, 60 times farther. Gravity should be 60 squared times weaker. That is 3,600 times weaker. On Earth, objects fall 16 feet in 1 second. If gravity at the moon's location is 3,600 times weaker, then the moon should fall toward Earth by 16 feet divided by 3,600. Calculate it, 16 feet divided by 3,600. That is approximately 1/20th of an inch per second squared. Newton calculated how far the moon should descend toward Earth in 1 second if gravity follows an inverse square law, and it matched perfectly. The moon is falling at precisely the rate Newton's law predicts. This was monumental. This wasn't mere theory. This was prediction. Newton took one completely independent observation, how rapidly objects fall on Earth, and connected it to another completely independent observation. The moon's orbital period and distance from Earth, two phenomena that appeared entirely unrelated, suddenly became unified by one law, the law of gravitation. There was no turning back. Newton proceeded further. He calculated what planetary orbital shapes should be if gravity follows an inverse square law. He determined they should be ellipses. And what do you know? Planets do travel in ellipses. Kepler had already measured this, but Kepler didn't understand why. Newton explained it. He achieved 3 confirmations from 2 inputs, as it were. Then more pieces aligned. The tides. Why do tides exist? Because the moon exerts force on Earth. But wait, if the moon simply pulls Earth uniformly, there should only be 1 high tide daily, correct? The water bulge on the side facing the moon. Yet there are 2 tides daily, roughly every 12 hours. Why? Some theorized Earth was pulled away from the water. Others believed the water was pulled toward the moon. Both were partially correct, but neither fully understood. Newton grasped what was actually happening. The moon, S force on Earth, and on the water is identical at equal distances. But the water on the near side is closer to the moon than Earth's center is. So it experiences stronger pull, and the water on the far side is more distant from the moon than Earth's center is. So it experiences weaker pull. Thus you get two bulges, one where water is pulled more strongly toward the moon, one where water is left behind because Earth is pulled more than that water. Two tides daily. Actually, Earth performs the same motion as the moon. Both orbit their common center of mass. The center of this circle lies somewhere within Earth. Earth and moon both revolve around their mutual center of mass. This water is displaced by centrifugal force more than Earth, S average, and this water is attracted more than Earth, S average. Regardless, the tides were explained, including why they occur twice daily. Many other phenomena became clear. Why Earth is spherical, because everything gets pulled inward. Why it isn't T perfectly spherical, because it is rotating. So the equator gets thrown outward slightly, achieving balance. Why the sun and moon are spherical, and so forth. As science advanced and measurements became increasingly precise, tests of Newton's law became far more rigorous. The initial careful tests involved Jupiter's moons through meticulous observations of their orbital motion over extended periods. One could verify very carefully whether everything accorded with Newton's laws, and it turned out not to match. Jupiter's moons appeared to arrive sometimes 8 minutes ahead of schedule and sometimes 8 minutes behind schedule, where schedule means the calculated values according to Newton's laws 8 minutes. That is a substantial discrepancy. Something was incorrect. But wait. It was observed that they were ahead of schedule when Jupiter was near Earth and behind schedule when Jupiter was distant. Rather peculiar circumstance. Mr. R. Famer, maintaining confidence in the law of gravitation, reached an intriguing conclusion. Light requires time to travel from the moons to Earth, and what we observe when we see the moons is not their current state, but their state from some time ago, the time it took light to arrive here. When Jupiter is near us, light takes less time to arrive. When Jupiter is farther, it takes longer. So he had to correct the observations for the time differences. And from the fact that they were this much too early or that much too late, he was able to determine light's velocity. This was the first demonstration that light doesn't T-propagate instantaneously. Consider what just occurred. We discovered light's speed not by measuring light directly, but by trusting the law of gravitation, that light doesn't propagate instantaneously. Consider what just occurred. When something didn't T-align, instead of discarding Newton's law, R. Famer proposed, what if light requires time to travel? And he was correct. I emphasize this particular matter because it illustrates something crucial. When a law is correct, it can be used to discover another one. By trusting this law, if something is amiss, it suggests perhaps some other phenomenon. And if we hadn't known the law of gravitation, we would have taken much longer to find light's speed, because we wouldn't have known what to expect from Jupiter. As satellites, this process has evolved into an avalanche of discoveries. Each new discovery provides tools for much more discovery. And this beginning is the start of that avalanche, which has continued now for 400 years in a continuous process. And we're still avalanching along at high speed at this time. But here is the crucial point. Once you know light's speed, once you measure it, you start noticing something extremely strange. Light always travels at the same speed. Always, no matter who measures it. No matter how fast you are moving. Let me make this concrete. You are stationary. You shine a flashlight. You measure the speed of the light emerging 299792458 meters per s-econd. Fine. Now you board a train, a fast train, moving at, say, half light speed. You shine the flashlight forward in the train, S direction of motion. Common sense dictates the light should now be traveling at light speed plus the train S speed. Just like if you throw a ball forward from a moving train, The ball moves faster than if you threw it while stationary. But that is not what happens. You measure the light. It is still traveling at 299792458 meters per second, exactly the same speed, you think. Okay, perhaps I measured incorrectly, so you accelerate the train even faster. 90% of light speed, you shine the flashlight forward again. You measure still 299792458 meters per second. You become frustrated. You accelerate the train to 99.9999% of light speed. You shine the flashlight you measure. Still the same speed light. S speed doesn't T add. It doesn't T combine with your velocity. It is always identical no matter how fast you are moving. This should shatter your intuition. This is not how velocities behave in everyday life. Velocities add if you are on a train moving at 50 miles per h-hour and you walk forward at 3 miles per h-hour, you are moving at 50. 3 miles per h-hour relative to the ground. But light doesn't do this. Light always moves at the same speed relative to you, no matter how fast you are moving. Why? Einstein realized what was happening. And it is so strange, so contrary to common sense, that even now, over a century later, people struggle to accept it. Time and space are not fixed. They're reflexible. They bend and stretch to maintain light. S speed constant. When you move faster, time slows down for you. Your clock literally ticks slower, and distances contract. The space ahead of you gets compressed. These effects are real. They re not optical illusions. They re not measurement errors. Time actually slows. Space actually contracts, and the amount they change is exactly the right amount to make light. S speed come out identical for everyone. Let me repeat that. The universe adjusts time and space, bends them, stretches them, compresses them to ensure that light always travels at the same speed for everyone. Light S speed is not just velocity. It is a structural constant of the universe. Space and time are arranged in such a way that this speed is identical for everyone. Now here is where it becomes even stranger. If you attempt to accelerate anything to light speed, something very peculiar happens. The closer you approach light speed, the harder it becomes to go faster. It is not that you exhaust fuel. It is not that your engine is powerful enough. It is that the object itself resists acceleration increasingly. We call this relativistic mass increase. As you go faster, it is not that you exhaust fuel. It is not that you exhaust. Your inertia increases. It becomes progressively harder to push you faster. And as you approach light speed, your inertia approaches infinity. To actually reach light speed, you would require infinite energy, which is impossible. So nothing with mass can ever reach light speed. Not because of some arbitrary rule, not because of engineering limitations, but because the structure of space-time itself prevents it. Light can travel at that speed because photons have no mass. Zero, massless particles can travel at light speed. In fact, they must. They have no choice. They're always moving at that speed, but anything with mass can get close. Very close, 99.9999% of light speed. But never quite there. The universe won. Permit it. Now you might ask, but why? Why is the universe configured this way? That anything with mass can get close. Why is there a speed limit at all? And here is the answer that is going to frustrate you. There is T, a deeper why. Light S speed is T, a speed limit imposed on the universe. It is a consequence of how the universe is structured. Space and time are not separate. They rewoven together into space-time, and space-time has a geometry, a structure, and that structure has a built-in conversion factor between space and time. That conversion factor is light, S speed. It is not that light is special, it is that space-time has a maximum rate at which cause and effect can propagate. Light happens to travel at that rate because light has no mass. But the rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still be there. It is a feature of the universe itself. Here is another way to conceptualize it. In everyday life, you think of space and time as separate things. You move through space, time passes. They re-independent, but they re-not. You are always moving through space-time at a constant rate. Always. But that motion is divided between space and time as separate things. If you are sitting still, all your motion is through time. You are moving into the future at maximum speed, 1 second per second. But if you start moving through space, you must divert some of that motion away from time. You are now moving through space and time, which means you are moving through time more slowly. The faster you move through space, the slower you move through time, and there is a maximum. If you could move through space at light speed, you would have zero motion remaining for time. Time would stop for you. This is why light doesn't experience time. From a photon's perspective, it is emitted and absorbed in the same instant. No time passes, the universe is frozen. You can exceed light speed, because you can have less than zero motion through time. That is the limit. That is the barrier. And here is the beautiful part. This isn't merely theoretical. We've tested this repeatedly. Particles in accelerators get accelerated to 99.9999% of light speed. And guess what? The closer they get, the harder it becomes to accelerate them further. Exactly as predicted. GPS satellites must account for time dilation. They moving rapidly, and they in a weaker gravitational field. So time passes differently for them than for us on the ground. If we didn't correct for this, GPS would be inaccurate by miles within a day. Muons created in the upper atmosphere by cosmic rays should decay before reaching the ground. Their lifetime is too brief, but they're moving close to light speed, so time slows down for them. From their perspective, they live long enough to reach the ground. From our perspective, they live longer because they're moving fast. Either way, more muons reach the ground than should, exactly as relativity predicts. It is not speculation. It is measured. Light speed, being a limit, is as well tested as anything in physics. So let us synthesize this. Why is light speed the limit? Because space-time is structured in a way that has a maximum rate of cause and effect. That rate is light speed. Not because light is special, but because space-time itself has this built inconversion factor between space and time. You can go faster because going faster would require moving backwards in time, which doesn't make sense. You can have negative time. You can reverse cause and effect. Light speed is the speed at which now propagates through the universe. It is the speed at which information can travel. It is the speed at which forces act. It is the maximum rate of change. And this process, this avalanche of discoveries, started with Newton figuring out gravity by observing the moon. Then Famer figuring out light, speed, by observing Jupiter's moons. Then Einstein realizing that light's speed is constant and deriving relativity from that. Then thousands of experiments confirming it, each discovery building on the last. Each new insight opening doors to more insights. That is how science operates. That is the avalanche that has been ongoing for 400 years. And we still avalanching along at high speed at this time. Light's speed isn't just a number. It is the key. It is the thing that unlocks how space and time function. It is the thing that reveals the universe is stranger and more beautiful than we ever imagined. And the fact that we can understand it, that we can measure it, test it, use it to make predictions, that is the beauty of physics. Not comfort, not simplicity, truth.